Let us take another example of a cotton reel which moves down with certain acceleration, and alpha will be its angular acceleration, and this point, let us assume that this point is fixed. Find the acceleration A and alpha, and the tension and the strain. Let the tension in the strain be T, and the gravity is mg. Under the action of these two forces, the cotton reel, or you can call it a disc of mass m and radius r, is moving. While doing so, this thread at this point, it doesn't slide, it comes down. So acceleration of this point P is equal to acceleration of this point Q. So this point does not accelerate. So that is the first equation, kinematics. Or you can put kinematical equations at last. Let us write the force equation with respect to center of mass. Then you can write torque equation with respect to center of mass. Then kinematical equation. So let us start force equation. Net force acting on the disk is T up, mg down, and that is equal to mass times acceleration we have taken down minus. So mj minus T is equal to ma, equation number 1. Next, torque equation about the center of mass C. mg passes through the center of mass, it cannot produce a torque about it. The torque is produced by the tension about the center of mass of the disk. That's equal to Tr, that's tau c, is equal to Ic into alpha. Alpha we have taken. The torque tau c is equal to Ic into alpha, and tau c is equal to T into R in clockwise sense, and that's equal to Ic, that is the moment of inertia of the disk about z axis, m square by 2 into alpha. Alpha I have taken in clockwise manner, so it is minus alpha kk. In this way you can get T is equal to m r alpha by 2, equation number 2. And third equation is kinematical equation, which states that AP is equal to AQ. Since this point is fixed, AQ will be equal to 0. So AP will be equal to 0. AP is equal to APC plus AC. That is APC plus AC. APC will be equal to R alpha up, and AC you have taken down. So A will be equal to R alpha. Substitute A from equation 1, substitute alpha from equation 2 in equation 3. Substitute A is equal to G minus T by M, and alpha is equal to 2T by MR from equation 1 and equation 2 in equation 3 to get G minus T by M is equal to R into alpha is equal to 2T by MR. R are getting cancelled. So J is equal to T by M plus 2T by M, that is 3T by M. So it gives us T is equal to mg by 3. Answer. Once you get tension, substitute here to get A is equal to G, T by M will be equal to G by 3. So axis of the center of mass of the disk, falling disk, is equal to G by 3, is down. Once you get A, either you can just write alpha is equal to A by R, that's equal to G by 3R. Answer. Or you can substitute the value of T here to get same answer. In this way you can solve this middle level or second grade problems. We have another method also. We can, since this is fixed, this is instant axis of rotation, about this also we can take the torque. This is method number 1. Let us resort the second method. In the second method, reference point is P. With respect to the reference point, the torque equation let us write tau P is equal to IP into alpha. Tau P is equal to, this tension passes through this point, therefore it cannot produce a torque above this point P. Gravity is producing a torque in clockwise manner, that is equal to mg into R minus kf. IP is equal to 3 by 2 mr square, and alpha I have taken in clockwise manner. It gives us directly alpha is equal to 2g by 3r. What we have obtained by using the method number 1, by following the center of mass method. Answer. The rest of the things will be as it is. In this problem, if this point accelerates up, what will be the changes? Let us write. Following the first method, you write mg minus t is equal to m into a. Force equation, and the torque equation gives us T is equal to T into R is equal to mr square by 2 into alpha. So T is equal to mr alpha by 2. These two equations as it is, no change. In the kinematical equation, there is a change. AP will be equal to AQ, because since the string is inextensible, these 2 points will have same acceleration. AP will be equal to R alpha j cap minus A j cap, and that's equal to AQ. Now AQ is now A naught j cap. So instead of A is equal to R alpha, it should be written A minus R alpha will be equal to A naught. Now substituting A from equation 1, that is equal to G by T by M. Alpha will be equal to 2T by MR. We can get A minus R alpha is equal to, it's not A minus R alpha plus minus A. R alpha minus A is equal to A naught. A naught is given. Alpha you substitute here, and you substitute the acceleration to get J minus T by M, negative of this, plus R alpha will be equal to 2T by M is equal to A naught. So minus J will be taken to right hand side, and you take T by M common. So you are getting 2T by M plus T by M, that is equal to 3T by M, that's equal to G plus A naught. So you are getting T is equal to M G plus A naught by 3. Answer. There is of course another method called pseudo force method. You can use the pseudo force method by sitting here, when you are accelerating the A naught up, you have to impose a pseudo force in addition to the real forces mg and tension. So here the force equation, or you can take the torque about this point. In addition to the torque of the real force gravity, you would take the torque of the pseudo force about this point to get tau p is equal to ip into alpha. Method number 2. Pseudo force method. Sitting on the non-accelerating frame, which moves up with the acceleration A naught, and imposing the pseudo force that is downward, opposite to the acceleration of the reference frame or the observer. Tau p is equal to mg into r in this direction, plus m A naught into r in this direction, is equal to ip 3 by 2 mr square into alpha in this direction we have assumed. So we are getting alpha is equal to j plus A naught 2 by 3. Answer. So after getting the alpha is equal to 2 by 3 into j plus A naught by r, if you can substitute alpha here, we are getting T is equal to m r alpha by 2. So m r by 2 into alpha is equal to 2 by 3 g plus A naught by r. So it is getting cancelled. Ultimately you are getting the same answer. So we can use the center of mass method or a method with respect to this point, that is called pseudo force method, because you should be careful, this point is accelerating. When you stand here, you have to apply the pseudo force, and in addition to the torque of the real forces, you have to apply the torque of the pseudo force about this point, and you can write rotational dynamical equation tau p is equal to ip into alpha. But tau p is the sum of the torques of the real force, gravity, and the tension. Since tension passes through this point, it cannot produce a torque, and the pseudo force is m A naught downward. Its torque also you have to consider. When you add it, you are getting the net torque that can be equated with the product of ip. It's not ic because you have taken this reference point p, not the center of mass. If you take the reference point center of mass, tau c is equal to ic into alpha, you are getting this equation. And once alpha you have got using this procedure, you can put the alpha here to get same tension. Or you can substitute the alpha what you have got by using the pseudo force method, and the acceleration you can calculate. Once you get the acceleration, substituting that acceleration in the force equation, you can get the same tension. Let us take the example of rotation about the fixed axis. Here is a rod. The rod is placed horizontal on this surface so that here sufficient friction is there, and the rod doesn't slip while it rotates. When you lift the rod, it rotates like this. It rotates about this edge point. About this edge, the rod will rotate. So this is the final position. When it rotates to an angle theta, this is the position. Let us draw the FBD, gravitational force acting on the rod. The tangential contact force, that is none other than the static force of friction, and normal reaction force N. Since it is fixed axis rotation, we have the facility of writing the torque equation about this point, a pivot, or generally also you can follow by taking the center of mass as a reference point to write the torque equation. However, the force equation will remain as it is. While we are writing the force equation, we will take the axis is x-axis, or you can call it tangential axis, and this is normal axis. Let us write the equation. But before that, let us mention the acceleration, the tangential acceleration, and this is radial acceleration. This is r axis, or you can call it t axis. Let us write the equation now. The reference point is P. To write the torque equation, about this point, these two forces pass through this point, therefore they can produce a torque about that point. Only the gravity can produce a torque, and the torque produced by gravity will be equal to mj into x. Which direction? Minus kf. And this tau p is equal to ip into alpha. About this, the rod has moment of inertia ml square by 3. The alpha I have taken in anti-clockwise manner, minus kf into alpha. This gives us where x is equal to L by 2 cos theta. So mg L by 2 cos theta is equal to ml square by 3 into alpha. This gives us alpha is equal to 3g by 12 into cos theta. From torque equation directly we are getting the alpha value. Let us assume that its angular velocity is omega. A linear velocity, let me vc. Once you get alpha, the acceleration of the center of mass in tangential direction, that is at, can be written as r into alpha. What is r? R is the radius of the circular path, because the center of mass is moving in a circular path about this point till this point doesn't slide, till the rod doesn't slide. You can put alpha, r is equal to L by 2. So that's L by 2 into alpha. Substituting alpha, you are getting L by 2 into 3g by 12 cos theta. So LL getting cancelled. You are getting 3g by 4 cos theta is the acceleration of the center of mass in tangential direction. And question, if the rod is left from rest from the given angular position theta, find alpha, find acceleration of the center of mass, and find frictional force, find the normal reaction. This is the question. And we have calculated alpha. And we are applying the kinematics. This is a torque equation. So you note alpha is equal to 3g by 2L cos theta. And tangential acceleration of the center of mass is equal to 3g by 4 cos theta. Let us write the force equation now. The force equation, taking this 2 as the axis. You can take it x-axis or r-axis, or you can take it y-axis or n-axis or t-axis, your wish. Along this direction, what is the net force acting? If you take this positive, this will be negative. If you take this direction positive, this will be negative, your wish. So this is the static force of friction. Force of static friction is Fs, and mg, if this is theta, this will be theta, this plus this 90. Well, so this will be mg sin theta. So Fs minus mg sin theta. Let us assume that this is positive and this is negative. And let us assume that this is positive, this is negative. Or you can take this for this negative also. Is equal to m into acceleration of the center of mass along radial direction. Since it is moving in circular path, the center of mass should accelerate towards the center of the circular path with an acceleration that is called radial acceleration or centripetal acceleration. Well, along this direction, the force component of mg is mg cos theta, is positive, and normal reaction is negative. And acceleration of this center of mass along this direction, we have taken at in this direction. This direction is called positive. We have assumed positive, therefore plus at. Two force equations, then kinematics. It states that for circular motion of the center of mass, AR is equal to R omega square, R will be equal to L by 2, and AT is equal to d by dt, and AT we have calculated, that's equal to R alpha. Alpha we have got by using the torque equation. The torque equation, these two forces will pass through the given point or this edge point. Therefore, they cannot produce a torque about this point. Torque is produced by the gravity about this point. That's equal to tau p is equal to I p into alpha. Already I have explained this. Mg L by 2 cos theta is equal to ml square by 3 into alpha. Alpha you have got directly 3g by 2 into cos theta by L. Of course. This is direct answer of alpha from torque equation. If you substitute alpha, you are getting 80. If you substitute 80, you are getting normal reaction. Let us calculate the normal reaction now. When you substitute alpha, how much you are getting? 3G by 2L into cos alpha into R is equal to L by 2. So, substitute now, L by 2, alpha will be equal to 3G by 2L into cos theta. You are getting 3G by 4 cos theta. So, 80 is equal to 3G by 4 cos theta. You substitute 80 here to get m into 3G by 4 cos theta. Then you are getting the value of n is equal to mg cos theta by 4 answer. To find the force of static friction, you have to catch this equation. Catching this equation, while you catch this equation, we encounter radial acceleration. Where radial acceleration is equal to L by 2 into omega square. Here, omega is equal to 0 because the rod is left from rest. Rest means both omega 0 and Vc 0. Rest means translational motion is 0 and radial or rotational motion also will be equal to 0. For translational motion is characterized by the velocity of center mass, that's equal to 0, and Vc is equal to 0, omega 0 must be 0 because Vc is equal to L by 2 into omega for motion of the center of mass in circular path. Well, when you substitute omega is 0, in this equation, we are getting AR is 0. By substituting the value of AR is 0 here, we are getting Fs is equal to mg sin theta. That's interesting. We got the value of Fs. We got the value of AC. Therefore, AC is equal to AT plus AR. Since AR is equal to 0, so AC is equal to AT, that's equal to 3G by 4 cos theta. In which direction? In this direction. So we got this. We got this. We got this. Another interesting question I can pose here. Question is, if the coefficient of friction at this point is mu, find the value of theta if it slips at that angle. If the coefficient of friction of static friction at the point P is mu s, find theta at which or for which the rod begins to slip or begins to slide. So for this you need to write an extra equation that is none other than the law of static friction, which states that Fs is less than Fs is equal to or less than equal to mu s into n. Here n is equal to mg cos theta by 4 and Fs is equal to mg sin theta. mg will be getting cancelled. Mu s will be equal to is less than equal to 4 tan theta, or you can just write theta is equal to is greater than equal to tan inverse mu s by 4, or you can write simply when it begins to slide both the sides will be equated, can be equated, because the force of friction will reach the optimum value, that's mu s into n. So we can give the equality sign and we are getting the corresponding angle. We can recheck all these equations, the calculations, whether we are correct or wrong. Well, we have checked all these things, all the steps, and we found it absolutely correct. And in the same problem, same set, you can ask by slightly changing the statement. The statement is that instead of releasing the rod from rest from this given position, if you release the rod from horizontal, it swings, then problem will be more interesting. And you can ask some question. And for this, let us change the statement. If the rod is released from rest from horizontal, it swings without sliding. Find frictional force, static, normal reaction, center of mass acceleration AR, and AT, and total acceleration. And then you can calculate the angle at which it begins to slip. If mu s is the coefficient of static friction. It's an excellent problem. For this, just you have to write the equations. What are the changes in the equations? I will tell you. Force equation, there is no change. mj sin theta minus fs is equal to m into ar, or fs minus mg sin theta is equal to m into ar. I have given ar in this direction and I have taken at in this direction. Ar will be obviously towards the point P, because this point is moving in circular path. It has to accelerate towards the center of the circular path. That's what we call radial acceleration. Equation number 1. And second equation, along the tangential direction or along the y direction. That is mj cos theta minus n. We are not writing any new equation, same equations we are writing, as equal to m into at. Then torque equation. mj L by 2 x is equal to L by 2 cos theta. There is no change in torque equation also. So alpha will get 3g by 2 L cos theta. Then we are writing canonical equations. Since it is moving in circular path, AT is equal to R alpha, that's equal to L by 2 into alpha. Fourth equation. And along the radial direction, the centripetal acceleration is equal to R omega square. R is equal to L by 2 into omega square. Now we have 5 equations and we have to calculate number of unknown quantities. They are Fs, N, AR, AT, omega, alpha. One, two, three, four, five, 6 equations. We need another one equation. And that equation will be the equation which relates alpha and omega. And that equation is kinematical equation. Alpha is equal to omega d omega d theta. Now, how to solve all these equations? That is the matter now. Now, we have 6 equations and 6 unknown quantities. Now, we can solve the equations very comfortably, but there should be a proper approach. The approach we follow is to set alpha here. Already alpha we have got in terms of theta. So, substituting alpha here, 3g by 2l cos theta, we are getting omega d omega by d theta. By separation of variable method and integrating both sides, we can get omega as the function of theta. By separating the variable, we can write omega d omega is equal to 3g by 2l cos theta d theta. Now, integrate both sides. When theta was 0, when the rod was horizontal, theta was 0. At that time it was at rest, therefore omega was 0. When it swings through an angle theta, its angular velocity will be omega. So, we are getting, if you just integrate it, you are getting 3g by 2 L sin theta. So, omega will be equal to, this will be omega square by 2 is equal to 3g by 2l sin theta. So, you are getting omega will be equal to 3g sin theta upon L square root of this. Once you get omega, you can get AR. We have got alpha, we can get AT. Once you are getting AT, you can put here to get N. Once you have got AR, you can put here to get the Fs. That's the idea. So, omega how much you are getting? 3g sin theta by L. So, omega square value you substitute, that is equal to 3g by L sin theta. So, the radial acceleration will be equal to 3g by 2 sin theta, that is AR. Substitute AR here, 3g by 2 sin theta. M into 3g by 2 sin theta. Here mg sin theta, here 3 by 2 mg sin theta. You are getting 5 by 2 mg sin theta. So, Fs you are getting here, Fs will be equal to 5 by 2 mg sin theta. Answer. A normal reaction, alpha, substitute alpha here. The alpha value is 3g cos theta by 2l. So, you are getting, it is 3g by 4 cos theta. Once you are getting as 80, substitute here, that's equal to m into 3g by 4 cos theta. mg cos theta minus 3mg by 4 cos theta. It will give us the normal reaction mg cos theta by 4. So you are getting normal reaction now. So other things you can calculate very easily. Already you have calculated. AR 80 and A will be equal to AR square plus 80 square because they are perpendicular to each other. By taking 3g by 12 common, you are getting cos square theta plus AR is 3g by 2 sin theta and 80 is 3g by 4 cos theta. So you are taking 3g by 2 common, you are getting sin square theta plus cos square theta by 4 like that. So you are getting the total acceleration. But we need to calculate the angle at which it begins to slip for a given value of mu s. That's very interesting. For that, we need to write the law of static friction, which states that Fs is less than or equal to mu s into L. So Fs you have got 5 by 2 mg sin theta is less than or equal to mu s into n mg by 4 cos theta is getting cancelled. So you are getting theta is less than or equal to mu s by 10 mu s by 10 tan inverse or is equal to tan inverse 0.1 mu s. This is a very interesting problem for advanced level. If you split the problem, you are getting so many problems for men's level. In this way, we can completely solve the problem. Of course, there is another method that is called energy conservation method. By energy conservation method, you can get omega as a function of theta. Once you get omega, differentiating omega, you can get alpha. For that, if you follow energy conservation method, you need not write the torque equation, because by writing torque equation, you are getting alpha directly. By integrating alpha, you are getting omega reverse. But energy conservation method will give you omega directly. By taking the derivative of omega, you are getting the alpha, and rest of the things will be simple. So by energy conservation, just within 1 minute also you can solve. Just you take these two positions, and the center of mass comes down through what vertical distance. Let's suppose y, and y is equal to L by 2 sin theta. Change in kinetic energy plus change in potential energy will be equal to 0. Kinetic energy change will be half Ip into omega square. Potential energy change will be minus mgy, that's equal to 0. So Ip will be equal to ml square by 3 into omega square is equal to mg, y will be equal to L by 2 sin theta. Are you not getting same omega? Omega you are getting 3 g by L sin theta. In this procedure also you are getting same omega. Omega is equal to 3g sin theta by L. Same omega you are getting. By following the dynamical procedure, you get alpha. By differentiating the alpha with respect to theta, we are getting same omega. And by energy conservation also you are getting same omega. Once you get omega, by taking the derivative of omega with respect to time, you are getting alpha.